Good afternoon, Robert Scribbler. It is September 6, 2018. Thank you for joining me for another climate change and clean energy video blog. Now, for this segment, I am going to talk about some rather disturbing model trends that show Hurricane Florence threatening the U.S. East Coast as a very powerful major hurricane of Category 4 or Category 5 status, potentially in some of the models next week. But before I get into that, I'd just like to talk about some dynamic potential changes and systemic trends related to human-caused climate change that are making the U.S. East Coast more vulnerable to hurricane impacts. And just to simplify, one of the major things that has protected the U.S. East Coast from hurricanes during traditional climates, particularly in the 20th century, is the influx of cold fronts or of troughs that tend to sweep in across the eastern U.S. as we begin to enter September. And these troughs have tended to pick up storms and pull them out into the central Atlantic, deflecting them away from the U.S. East Coast. Any change in this longer-term pattern, this longer-term trend of troughs running in through the eastern U.S., and deflecting hurricanes out into the Atlantic would tend to result in less protection for the U.S. East Coast. And it's worth noting that I'm going to talk about a meteorologist that's talking about just this topic on his blog. That's Guy Walton. I'm going to go ahead and provide a link for you just so you can get some more context about this. But it does look like Sandy was an indicator of a potential weakness in the typical deflection of storms off the U.S. East Coast due to troughs running through, and that over time, as the tropics warm and as the typical weather patterns are moved north, and as ridge patterns become more prevailing, as well as fixed ridge and trough patterns due to human-caused climate change, you tend to have more of an opening during times of these stronger ridge patterns for storms to impact the U.S. East Coast. Now, looking at the present situation, what we see is a ridge pattern affecting the U.S. East Coast. The predicted trough patterns failing to emerge, Gordon pushing the trough in toward the central U.S. and reinvigorating the moisture flow and the bulge of heat and moisture across the U.S. East Coast, as well as some upper level steering currents that are coming into play that look like they could turn Florence toward the U.S. East Coast, as well as much warmer than normal sea surface temperatures off the U.S. East Coast that could provide a serious amount of fuel for Florence as it approaches the U.S. East Coast. So just some things to think about as I go through this analysis. I'm going to look at the forecast track from the National Hurricane Center for Florence. And as we can see, the National Hurricane Center brings Florence as a major hurricane just south of Bermuda by 8 a.m. Tuesday. And it's at that point that some of the models pick up a very serious and potentially dangerous forecast for Florence as we move into the middle of next week. I would like to add that these model forecasts at this time, 1 week in advance, are very uncertain. And to predict a landfall of such a severe system at this time is an exercise in, we would say, folly. But what we want to say is that Florence is now a serious risk for the U.S. East Coast, and we need to keep an eye on it. Now I would like to just show you a very scary model. So this is the global forecast system model. I am going to track it back to predictions for Monday, September 10th, and I'm going to go ahead and advance this model. And so what we see is a 932 millibar storm. This is would likely 932 millibar storm would likely be a strong category 4 or potentially a weak category 5, but a very, very strong storm. Moving off the U.S. East Coast and directly across the offshore from the North Atlantic as of Wednesday, as a 930 millibar storm, dipping down to 927 millibars, approaching the U.S. Northeast coast. This is a very, very dangerous situation, very powerful storm. Now, it's worth noting that this is possible due to very warm sea surface temperatures off the U.S. East Coast, as well as a prevailing ridge pattern pushing away the troughs, and two high pressures that are providing a slot for Florence to approach the U.S. East Coast. Now, advancing this model further, we see an impact of a very powerful hurricane along the U.S. Northeast coast, ranging from Long Island to Rhode Island to Connecticut to Massachusetts by Friday, with a storm looks like in the GFS model either brushing or striking the Northeast coast at this time before button hooking back off the U.S. East Coast and strengthening again before being finally pulled out to sea as it is caught up in a trough. So a very dangerous and risky potential future for Florence as it approaches the U.S. East Coast. I also want to just note the upper level steering patterns. Let's see how much time we have. Okay, about 2 minutes. So we're going to focus in on some upper level wind patterns that are starting to provide a potential for Florence to impact the East Coast as a major hurricane. And what we see is the ridge pattern pushing off toward the north near Canada, a upper level high pressure system to the north of Florence, which will tend to pull Florence toward the U.S. East Coast, as well as a upper level low here, providing an atmospheric slot drawing Florence toward the U.S. East Coast. I'm just going to go ahead and note the pressure patterns. Now this is Florence. We can see the outflow, upper level outflow from Florence here, as well as the low pressure circulation, a bit of a high here, an upper level high, as well as the upper level low. And just advancing this, we see Florence pulled into this slot here as the ridge pattern maintains, and then again pulled toward the U.S. East Coast between a couple of upper level ridge patterns predicted to emerge in the GFS model by September 10th. So a rather serious situation for the U.S. East Coast, one that has a number of fingerprints of human-caused climate change on it, and one that may hint at an eroding defense for the U.S. East Coast as troughs tend to remain further to the north, and as the potential for stronger ridge patterns tend to develop off the U.S. East Coast due to human-caused climate change. Thank you for joining me, and I'll be chatting with you soon.